All right, let's look at the hallmark 4.3, problem number 4. All right, so I'll do the partial fraction portion of the problem. All right, so we have s squared plus 3 over, we have quantity s squared plus 2s plus 2 squared, right? So we can split this into, all right, so you have as plus b over s squared plus 2s plus 2 plus, all right, so you're going to have a cs plus d over, you have the same thing, but we have to square that. So we have 2 squared. All right, then combine these two. You can see that taking the common denominator back together. So of course it's going to be s squared plus 2s plus 2 squared. All right, so this one we have to multiply the denominator by itself. So we're going to multiply the numerator by the same thing. So we have, let's say, as times s squared. Maybe I'll write that down. So you have as plus b. And then we have to multiply by s squared plus 2s plus 2. All right, then you have cs plus d, so you're going to have add the cs plus d. All right, so we just have to match the numerators together. So here, all right, so I'm going to go ahead and multiply it out. So I'm going to distribute as to each term. So do that. So we're going to get a s cubed, right, plus 2a s squared plus 2as, right? Then we distribute the b to all three terms, like that. So you're going to get plus bs squared plus 2bs plus 2b, right? And here we don't have to do anything, so you have a cs plus d, right? And we have to make sure that this is equal to s squared plus 3, right? So what I'm going to do is I'm going to collect the like terms. So here, s cubed. So I'm going to just list the coefficients. So here you have s cubed, right? And the coefficient is a. And actually that's the only s cubed term. And the right hand side there is no s cubed, so we have to make sure that there is no s cubed, so we have it be 0. Right? Then when you look at the coefficient of s squared, right? So here's s squared. So you have 2a. So I'm going to write the 2a here. And then you have bs squared, so plus b. And I think that's it. So this has to be equal to, all right, right hand side you have 1s squared, so you have to make sure that it's equal to 1. But remember that the a is already 0, so this tells you that the b is equal to 1. All right? Let's look at the linear term, s term. So we have, there's a 2as, so I'm going to put that 2a. And then you have another one, so 2bs, so you have 2b plus 2b. And we have cs, oops, so we have a cs right? So plus c, right? There is no s term, so we have to make that equal to 0, right? So, but remember that a is 0 and b is 1, so it's a 2b would be 2 plus c is equal to 0. So we know that by subtracting 2, we know that the c is equal to -2, right? And then look at the constant terms, so just put 1. All right, constant terms are 2b plus d. So we have 2b plus d. All right, this is equal to 3, right? And then again, b is equal to 1, so this is going to be 2 plus d is equal to 3. So we know that by subtracting 2, we know that the d is going to be equal to 1. Right? So we can rewrite this guy as, right? So a is 0 and b is 1. So it's going to be 1 over, right, s squared plus 2s plus 2, right, plus, and c is -2, so you have a -2s, and d is 1, so it's a plus 1 over s squared plus 2s plus 2 squared, right? Then we can complete the square. So if you complete the square, you have s squared plus 2s plus 2, and then this is going to be equal to, right? So I'm going to do is s squared plus 2s. You need 1 to complete the square, but we have to have 2, so you're going to have extra 1. Right, so this is going to be simply s plus 1 quantity squared plus 1, right? So we can further rewrite this thing as 1 over, right? So you have s plus 1 quantity squared plus 1. Well, you can put 1 square if you want, and plus, right? So you have a -2s plus 1 over, here we just have quantity s plus 1 squared plus 1 quantity squared. All right, so one more thing I'm going to do is I'm going to make sure that we see the translation there. And the first term looks nice, so I'm going to keep it as it is. S plus 1 squared plus 1. All right, here, what I'm going to do is I'm going to write it this way. So you have a -2 s plus 1, right? So if you do that, you have a -2 times 1, so it's a -2 instead of plus 1. So what I need to do is add 3 to make sure that we get exactly the same thing. And then over, right? Then we have quantity s plus 1 squared plus 1, then whole quantity squared. Alright, so I'm done with the partial fractions. Then we just have to apply the formula for the inverse Laplace transform of this guy. And you need to probably split the second term into this portion here and the second portion there. And then you should be able to get that answer. Alright, that's it. I hope that this was clear.